Here you will explore a second strategy for graphing a sine or cosine function in standard form. You are going to graph the function y equals 1/3 the sine of 2 times x plus pi divided by 2 plus 1. First, graph the basic function y equals the sine of x. You can find 5 key points that are easy to work with on each cycle of a sine or cosine graph. Key points occur at the maximum values, the minimum values, and the midline values. Using the basic function y equals sine x, start when x is equal to 0. This gives the first key point 0, 0. The next 4 key points are the maximum pi over 2 and 1, the median point pi and 0, the minimum 3 pi over 2 and negative 1, and the second median point 2 pi and 0. Note that from the starting point, the graph must complete one full period in 2 pi. That is, it should go through its maximum, its minimum, and return to the median point. Let's leave this for a moment. Now compare the original equation to y equals a times the sine of b times x minus c plus d. You see that a is equal to 1/3, b is equal to 2, c is equal to negative pi divided by 2, and d is equal to 1. You know the absolute value of a is equal to the amplitude, so the amplitude is 1/3. The period is equal to 2 pi divided by b, so the period of the graph is pi. There will be a phase shift to the right c units. In this case, c is negative pi divided by 2. Therefore, there is a phase shift of pi over 2 units to the left. Finally, d gives the value of the midline, which is 1. Now you are going to use the phase shift to determine what we'll informally call the starting point of one cycle. On the graph of y equals the sine of x, you often think of the starting point at x equals 0. Applying a phase shift to it results in x equals negative pi over 2. So begin one cycle here. The period is pi. Within one period, the curve goes to a maximum and a minimum and back to the midline. Divide the period into 4 equal quarters because the key points divide a cycle into quarters. Each quarter is then pi over 4. So the x values will occur at negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. You can now find the new maximum and minimum values using the amplitude and the midline. The maximum is equal to the value of the midline plus the amplitude, and the new minimum is equal to the value of the midline minus the amplitude. If you remember the original starting point for y equals the sine of x, it occurred on the midline. So the first and last key points on the new graph will also appear on the midline. If you were using a cosine function, you would start with a maximum for a positive a and a minimum for a negative a. Both a and b are positive, so the second point remains a maximum like it was in the original graph. So mark the second point at x equals negative pi over 4 at the maximum line. The third point will cross the median again at x equals 0. The second point was a maximum, so the fourth point will be a minimum at x equals pi over 4. And finally, the fifth point returns to the same height as the first point to complete the cycle at x equals pi over 2. You can use the key points to connect the dots and continue the pattern. It may be helpful to mark where other periods begin to help keep your graph proportioned correctly.